So agenda-wise, we're back to abstract classes and interfaces. I'm trying to clue you guys in a little bit more on this topic. Okay. So I've got some additional examples, and then I want to go through an implementation for assignment 4 in class with you, because the hopes in assignment 5 are pretty high when it comes to applying object-oriented design. Okay, I want you guys to totally apply the stuff we have learned so far and abstract classes and interfaces. So my hope is in the first hour of this discussion, even though we have talked slightly about abstract classes and interfaces, I promise I'll come in with examples and show you some of these things. I'm going to do that now. And then we'll do some coding in class to kind of go over the idea that was presented last time to build the abstract class, to use abstract classes and interfaces in assignments. So to then begin the discussion, I want to just bring to your attention some basics about abstract classes. So abstract is something that's not concrete. It depends on something else for its existence. It cannot stand on its own. But yet, when we work with abstract classes, it enables ease of communication. If we look at the English language, for example, we talk about music and emotions and classes and college and school, and all these things are abstract. I'm going to school. I'm going to class. I'm thinking of something. You know, you're talking always in abstract mode. You're never really distinctly saying, or you're not talking in concrete terms. If we were talking in concrete terms, we'll be very specific, right? So that's why justification of abstract classes is for that reason, because even in the language, it enables us to communicate easily, right? So when an abstract class is created, we usually say abstract class, my word, beginning, or abstract class, emotion, beginning. I don't know what an emotion is until my emotion is extended, right? So we can say instructor feelings extends emotion. And we have beginning. Now it's likely that in an abstract class, I might have an emotion that's defined as abstract, right? Like what? So we will have maybe a variable called feeling, and we will say abstract void define feeling. So we have implemented a contract for all child classes, right? So what this means is that the instructor feeling class needs to implement the abstract method. Otherwise, we are going to get a compiler error. And you will say, so that's a feeling right there. I'm not writing, the full print line, whatever. But the emotion has a feeling now, right? Define feeling method is set. And maybe this could be Java instructor feelings, because to be more specific. So keep in mind that when an abstract class is written, it doesn't have to have abstract methods. But if a class has abstract methods, it must be defined abstract. Okay? We've already talked about all this. This is a nice review, if you will. There is no limit on the number of fields or methods. It's just that if I wanted to instantiate emotion at this point, I cannot do that. This will be a runtime error. Actually, a compile time error, excuse me. You cannot instantiate abstract class. Why? That's the nature. It depends on, the abstract class depends on being extended to be useful. Okay? So emotion, feel good, new emotion is a compiler error. So what do? Well, you can say emotion new instructor emotion is equal to new instructor feeling. So, okay? I can email you all this so you guys don't have to, sit there and type. So abstract class defines this contract. So all child classes extending the parent class has to implement the method. And you can always have more than one. And we can say student feelings. Feeling good, learning job. And that polymorphism aspect, because this is similar to overriding, right? So you can use polymorphism as we have learned before. So the question that comes up is, why use abstract classes? Well, define common methods that you can in parent. But you can also argue that I can do that in a normal concrete class. But doing it in an abstract class limits that class from being instantiated. And you can define and you can also declare. You can declare common methods that child must implement. And it cannot be, you can also create a dependency on other classes for instantiation. If somebody's asking you these questions about abstract classes, right? Why would you use an abstract class versus a concrete class? The fact that you can declare a method and the fact that you create a dependency, right? You have thus created a abstract construct, an abstract way of defining something. And it's also reusable. Please use examples from real life, like English language. Because one of the problems with textbooks is they are looking at some very concrete things to explain abstractness. And that's a hard problem. As you look at your life, Pretty much everything around you is abstract. When you look at a building, it's abstract. When you look at a cafeteria, it's abstract. You look at coffee, that's abstract. Every word I look at is abstract. Key, lock, table, chair, monitor, everything is abstract to me, unless you get specific, right? And you can delve into this for hundreds of examples. So that's what I mean. Please use examples from real life, and understanding an abstract class is therefore not a hard construct, especially if you can visualize in your head how it exists in your physical life, right? The matter of technical implementation is all right here. So these are the basics. These are the atoms of abstract classes. Now we need to get into more complex aspects, meaning look at more examples, right? And in this discussion, we are only going to focus on atomic aspects and not make life too complicated, because that's what, when we get into advanced implementation of abstract classes and interfaces, we will look at it more. Your question, please. This one? So you're asking why define common methods that you can in parent. These are, so what is the difference between a method declaration and a definition? This is a declaration, and it's declared abstract, which means the child class must implement. This, however, is a method definition. And you can add methods like these as well that would be common to all emotions, and you could define those methods here. That's what we are saying by that comment. So what is it about emotion that's common to all emotions? Well, you have to be able to print the emotion. You have to be able to define the emotion. I guess that is already there, right? Yeah, totally. So I can have a method. That's what I'm saying here. So let's add that. I can have a concrete method. And I can have constructors. So it's like a regular class. So I know my print is not print like a syntactically full print, but I can say feeling is plus feeling. And to make this legal, I can say system.out, because I guess. Okay, does that answer the question? So I will just have another method, right? It's like normal class. Right. It will override and it will call. Well, it can override if it needs to. Right. It will have it. What it must define is the set of abstract methods in the parent. No, it doesn't have to. It can just use them. So if you want to, this way you put all common things. And so everything about emotion that you know from psychologists, you can put in the emotion class. And then you say, okay, now I want to tackle different types of emotions. So abstract classes can have child abstract classes, because until you get to a level of specificity on emotion, it's going to be abstract, right? So you can imagine most things in life do end up being abstract. I think I've said enough on that, so I'll get off that horse and move on. Is there another question? No, you can do, so you're asking, can I write code in an abstract class? You can. And can you declare methods in an abstract class? You can. You can do both. The only difference is that when a child class extends an abstract class, it must implement the definition of all methods that are declared abstract. That's like it's not overriding because there is nothing in the parent to override. It's just a declaration, right? So you're saying, why would we even do this? Well, let's leave interfaces out for a moment. Well, I'm not ready for that right now. I'm not ready to address interfaces yet because that's a discussion that comes in after abstract class. Now, why would, right now if you keep in mind concrete classes and abstract classes, why would you declare methods and not define? See, at the time of design, you might just know the what part, but not the how. No. Let's not fly into another zones. I'm designing a class. I want to leave the implementation to the child class. But I just want to say what the method should be. I want to control the name of the method. I want to control the signature, meaning what input is given and what return value I get. So if I want to just control that piece, I use the term contract. In fact, I don't use this term. The Java tutorial brings this up, and I really like that because when you establish a contract, then child classes must implement them. So there is a nice side effect of that you get polymorphism, right? Now, your question about abstract classes versus interfaces, right? I'm going to address that in about 30 minutes when I get to interfaces, right? But there is a difference between abstract classes and interface. And right now I'm in the zone of abstract classes and I'm requesting your very close attention to this. Why use abstract classes over concrete classes? And you guys should be able to address that question very easily. Then the next question is obviously, hey, why would I use interface, right? And that was what I think you were asking. It's a really good question. I just need a few more minutes. Yeah, you can have a parent class called shape, and then you have triangle, rectangle, and circle, and you want to compute the area. So you could declare a method called area. So for polymorphism purposes, for communication purposes, we're just going to get an area of shape, no matter the shape. And so shape becomes the parent class, area becomes an abstract method. Every class, triangle, rectangle, circle, others, extend shape must implement the area method, and they're all doing things in their own, they're singing their own song, so to speak. But they're talking in a common language. So the behavior then becomes polymorphic, right? There is no way to define area in parent because it can just be declared. So then that becomes a really good facility, and therefore the job security, if you will, of abstract methods in an abstract class, right? So this is thinking in generic terms, right? This is not thinking in concrete terms. Thinking in abstract terms. Well, abstract classes, right? So what do you expect, right? It's going to be abstract thinking. So, okay, let me just look at these. I uploaded a few examples for you guys, so time is abstract. So I've got an example here with getMinute. Am I talking about time in days or hours and minutes? I've got two classes, child classes, right? So each one writes its own method. You don't have to, I mean, this is uploaded for you, so you can download these methods and take a look. So time, right? Need I say more on this example? Animal. There are real methods. Well, there is a constructor for an animal. It's abstract. It cannot be instantiated. So an abstract class in this case is representing an abstract idea, animal. And I've got the name of the animal that I can set. And I've also got the sound of the animal. I don't know what sound does the animal make, but anytime I want to know the sound of an animal, I just say, give me the sound of the animal, right? It's an abstract method. It doesn't return anything. And I'm just hoping because it's Java, we're not going to play any sounds, we're just going to print them. So now we have got cat and dog and bird, and they've got the constructors, and we've got the sounds. Yeah. So now we go in and we've got the cat and the bird and the dog. These guys are you're familiar with. Now cat, bird, and dog is a child class of animal. So we up cat. We assign cat, which is a child class of animal, to animal. And then we say, get the name of this animal and play the sound of that animal. Right? Then the bird becomes an animal and we get the name of that and we play the sound. Dog becomes an animal and there we go. Right? Abstract class. Yes? You were talking about shape earlier. Well, I got that covered too. I've got shape with height and width and area. And I don't know what the area will be, but I got a rectangle and a triangle. I might as well add a circle. Each one has a different method for computing the area. By virtue of extending shape, I must write the area method. So you can see I've got a shape. I do the same thing. Rectangle becomes a shape and triangle becomes a shape. But here is the reason, right? Why do you need the rectangle and triangle to become a shape? Why? Why do we need an abstract class here? Guys, the idea is common lexicon. So in English, if I say the area of this shape is 13, right? I am able to use that sentence for many different things. In English, you often say, when you're communicating with people around you, I'm going to class. You don't tell them you're going to go learn Java in room ATC blah blah and with instructor blah blah. You're not getting specific, right? That's what I mean by communication. The implementation of polymorphism. So here is a sentence that describes, right? The implementation of polymorphism without defining the method is the need for an abstract class. Because by simply declaring a method and enforcing a contract, I'm able to get the child classes to do their respective implementations, and through polymorphism, I can call upon those methods when needed. And that's a very clear-cut need for abstract classes. Question? No. So, well, circle can have, I mean, width can be an overloaded property. You could. See, you cannot say shapes are constrained by one or two properties. The fact that, so just to kind of repeat the question, that if I create a class called circle, height and width has no value. And maybe I need radius. So what do? Do I make circle a child of shape? Well, it is a shape if you really think about it. So if that means you want to add one more property called radius, please do it. Now, it turns out that triangle and rectangle have no reason to use radius. But so what we are saying is it's okay to have properties in the parent class that are necessarily not a subset of what the child may need. And neither it has to be superset. As long as in your comments and your practice, you're making it abundantly clear what the properties, how the properties are to be used and why you declared them. So folks, this is where comments really help out, okay? So, are there any other questions before I move on, please? Is it okay to put the radius property in the circle class itself? Because it has no bearing on other. That's actually a better way to go, because you can have specificity in a given class for its properties, and you don't need to burden the parent or the abstract class with things that don't belong there. By virtue of a good design, you would want common properties only. That would be nice. So, yes. So we are saying, are you saying putting a rectangle class inside shape class? Sure. So depending on the types of shapes, if you were dealing with circular type shapes or, line type shapes, we could create child classes that are abstract that could have these properties for a better definition. And that could even be going one step further. Totally. Okay. Let's go to interfaces. So an interface plays many roles. It becomes a bridge between groups of classes using inheritance. Okay? It can become a bridge between classes. It can be used for enforcing a contract without using external in different classes where extent cannot be used. And then, of course, there are many other benefits of interfaces, but let's just start with these two, right? We could also say the side effect of enforcing a contract could also be hiding complexity, which is what you're going to realize in our first implementation. I'm going to try to do that with an example today. So you declare an interface. It's usually declared as a public class. And I can declare some public methods. So now, when a class implements, it must write these two methods. Unless the child class or the class that's doing the implementation is an abstract class. So I can also have so then these implementations are not required, because this particular abstract class has to be extended anyway, and so it can burden its child with the responsibility of the implementation. Okay? I'm just covering the syntactical pieces of working with interfaces so you can use it. Okay? So there is actually much less to say on interfaces than abstract classes from syntactical standpoint. Can you do method definitions in an interface? Like, not really. But we're going to change that too if we were to bring in inner classes, which is another construct we're going to talk about, right? But not today. Can you declare constants? If you want a global variable, what better place to put it than an interface, you see? You put a public constant declaration, and you implement that interface in every class, and it could be public, right? So a good one would be public final Boolean debug equals false. And then I could go in my implementation, right? And I could say if debug, then system.out.println tail minus f, if you know what I mean. The idea is that I'm printing out print all debug information. So if I'm putting my code in a production environment, and I now only have the executable, I could set up a way to perhaps pass in this debug flag as true or false through command line argument, and I could get more information on what might be going on in production when I turn the debug mode on or off. So debugging in compiler is using the debugger and stepping through the lines. Debugger in production is print lines and this global flag. at least for now. And as we progress further, you'll find more sophisticated tools around this. So, okay. So let's look at some examples that I've put up for you guys. So I've got time again, right? I've got get minutes. I've declared a method, and I've got time in days. I've got minutes in days, and I've got minutes in hours and minutes. So abstract class and interface, both. Okay. Then I've got another interface that's, a bunch of constants. Why not? Did you have a question? Correct. If I say class A extends fun, and your question is, so class A will now need to implement the method 1 and 2 declared in my API, because whatever is implemented or inherited gets inherited in layers. So how will I know? Well, the programmer would know that you're working with Fun class that has my API, and my API has 2 methods, and therefore it's my responsibility now to put method 1 and method 2 implementation in class A. You just follow the hierarchy, right? It's a way to enforce a contract. Okay? And the compiler will give you a compiler error too, of course, naturally. With hopefully a little less reliance on that versus our own hunting. But then again, tools in software engineering are becoming very sophisticated to the point where you can do debugging on production environments in runtime, in the cloud, on the fly. So there's a lot of cool things that are there today. Okay, back to the example. An actor will act. Okay? Pay very close attention to this, folks. And I think to help you out, what I'll do is I'll draw you guys a little picture. That is not a class diagram, but it is something to help you keep track of about 10 classes that I'm going to throw here. So Act is the interface. Can you guys see that? No? Okay, so for your eyes only. Act. What is Act? It has an Act method. An actor is supposed to act. Okay, so the actors implement Act. I'm not going to draw all the arrows. there is actor 1 and there is actor 2. And both of these guys, both of these actors are going to go into a tryout. Do actors do that pretty frequently? And actors get a static method, right? And in the tryout, we pass an interface. So there is a method called tryout, lowercase t, and both of these actors can go in a tryout and act. I want you guys to see the polymorphism in play here. You see it or you don't? Huh? I'm getting one yay, one nod. Actor 1 and actor 2 implement act interface. Act interface declares the act method. So when actor 1 implements act, that's like the Romeo and or Juliet, I guess. And actor 2 is the Romeo, I guess, right? Oh, I'm sorry. Whatever. But both of those actors, because each actor 1 and actor 2 class implement act interface, we can pass both of those instances through the act interface in the tryout static method, right? So look at the main, right? We can say actor 1, actor 2, tryout Hamlet, tryout Juliet. And here we say actor.act. So actor 1 is Hamlet, so we'll print out to be or not to be. And with Juliet, we'll print out wherefore art thou Romeo. You get Shakespeare even in Java for free. Question? Yes. Right. Right. Now, actor 1 and actor 2 can extend other classes because extends is still available, right? But act became a bridge between actor 1 and actor 2. No. Classes. Sure. We don't call actor 1 and 2 child classes, but we call them concrete classes implementing interfaces. What did actor 1 and 2 get by implementing this interface? Well, actor 1 and 2 became part of the act family. How do you become part of a family? By speaking the language in Java, right? It became part of the family by being part of the act method. Say, I'm going to act anyway, so instead of calling it my acting or something else, I'm just going to call it act. And so you get polymorphism enabled. Okay? Sure. Sure. Actor 1 and Actor 2 can extend emotion, hopefully not instructor emotion, because Shakespeare and Java won't make. That was just a stupid joke, but never mind. Yes, you're right. Actor 1 and Actor 2 can extend other classes. Okay. One more example, and please be ready for this. Okay. And this is where you'll really see the power of interfaces, I think. So I'm going to declare a few interfaces. As you can see, can fight, can swim, and can fly. Okay? And we have an action character. That can fight. In fact, let's forget about the action character from this puzzle, because that's just introducing another level of complexity that we don't need. So we'll forget about this, and we will just say we have a hero that can do all three. A hero is implementing fight, swim, and fly. So you can see this, sorry, limited real estate. So you can see this. Hero can do all three. Now we're going to go and have a little bit of adventure, right? So here is my adventure class. And adventure class has P, U, V, and W. Okay? Those are static methods. So in adventure, I can say sorry, one moment, please. I was trying to get this text to be on the top, but I guess we'll do it this way. So there is adventure. So in adventure, I have a method called T, and I'm saying can fight X. And then I call the X.fight. So let's take this code and essentially plug it in here. So visually, I'm basically going through, this guy is going through this method. I guess we need our line to be a little bit thicker. And it needs to be brought to the front so you can see it. That's my problem? Yeah. So the point that is being made here, guys, is CanFight is an interface, right? And it's going through this, and obviously we're going through that interface. And Hero has all these methods, swim, fly, and fight. But from X, I can only call X.fight. If I try to call, so just to make a point here, if I were to call X.fly, that's going to be a compiler error. Why? Because fight cannot see swim or fly in Hero. And vice versa. Fly cannot see swim or fight, swim cannot see flight or fly. So if you get that, that is the reason to use an interface. So now I come to my point of interfaces as implemented in our life. I am an instance of a human class that has many can capabilities. I can do many things. But all you guys in this class see is my Java skills. You don't see my project management skills. You don't see my personal life. You don't see all the things I like to eat, right? So there are all these capabilities. Eating is also a capability, right? So all human beings have these different capabilities. Now, if you think about it, and please really focus on this seriously, you use interfaces every day, don't you? When you're communicating with others. If somebody tells you, I know you 100%, that's impossible. Because what you don't say and what you think is so dynamic, you know, those classes in you, the Hero, are being implemented on the fly. So it's impossible for to know someone 100%, even if all your methods were exposed, right? So please realize the job security of interfaces is in exposing functionality that you want to be seen. Now, if you want to go find a job, what you have to do is make sure you present a really good interface. That's your resume. If you cannot find a job and you have the skills, you are failing in your public interface. So if you do a good job of publishing your skills in an interface, in the right words, with the right skills, people will see that and you will find a job. And finding a job today in 2015 with all the tools you guys have is not a hard thing, especially when the economy is getting better. So you need to implement, first you need to declare proper interfaces, and then you need to make sure that your implementing class implements those really well. So interface becomes the basis of communication, as is abstract classes, right? If you think of interfaces, bridging different classes, because today we have Hero that can fight, or swim or fly. And it's not too far a thing where you can get, I mean, Hero is nice, but why not Marine? Why not well, if I can say CIA cop. You know what I'm talking about. So these capabilities, right? And this is another thing I'm trying to draw your attention to is that you can have these capabilities declared in interfaces, but then multiple classes can implement those. And you can have a mesh of capabilities in different objects, and you can pull in those things on me. Okay? And you can only do this with interfaces and not with abstract class. This was why I wanted 30 minutes. Because if I tried to answer a question in any other way, I would fail, as I have before. Yes? Yes. Right. 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 I mean that is a tough question right now, because you're going in the question you're asking that there is a LinkedIn job with 10 skills, and I have my resume with 5 out of those 10 skills, but 15 other skills, right? And I'm trying to do a match, right? How is an interface implementation in this context? It is visually shown likely. It is shown likely with these 6 classes, but I'm not quite ready to address that at this level. But it is a fantastic question, right? What I can say is that you can hopefully see that how can fight, can swim, can fly class can, or these interfaces can become a bridge between Marines and CIA, cops, and heroes. Because if these 3 classes implement all of these interfaces, then they have all these capabilities. And can swim, can fly, can fight allows access to Marine, CIA, cops, and heroes. It becomes a bridge for the fight method across those 3 classes. Okay? So, yes. Sure. So this is another way of looking at interfaces, that can fight, can swim, can fly are capabilities that are populated perhaps in a form, an interface. And the implementation of those is in classes like Marines, CIA, cops, and hero. And depending on which object we want to access, we can go ahead and pull the fight method from Marine, CIA, cops, or hero dynamically. Totally. So I think I've covered interfaces and abstract classes. What I'd like us to do is maybe take a mini break. And when we come back, I would like to talk about assignment 4. After.